In this video, we're going to be talking about how we can check our work when solving equations. Equations are like an expression that we've talked about already, but instead of just being the statement, like in here, 6x plus 32, we now have an equal sign which is creating an equation. So it's saying that our expression 6x plus 32 must be equal to -4. So what we're going to be doing is we're going to be solving equations, and we're going to find out that there's only one true x value that will work for each equation. So we need to learn before we start solving them how we can check to see if our answer that we get is correct, because that's the most important thing during this unit is that we're going to show our work and solve everything, but in order to know that we did it right, we need to be able to go back and check our work. So in the first example, it says which value of x will make the equation true. So I have this equation that says 6x plus 32 is supposed to equal -4. And in my first box here, it's asking me to replace x with -1. So I'm going to replace the x value here with a -1. Remember that when we have an x value next to our number, the 6 is the coefficient and our x is our variable. That means it's multiplying, so we can either use the dot or parentheses to show that it's multiplication. We're going to add 32 to that and then see if it's equal to -4. So I'm going to follow GEMDOS because I'm trying to figure out, well, is this going to turn into -4 or simplify to -4? 6 times -1 would be -6 plus 32, and that leaves us with 26, which is not equivalent to -4 like we were expecting. So this value will not make the equation true. So this is not an x value that works in this equation. If you think you get it, go ahead and pause and try the other two on your own. Otherwise, keep listening and see if you get it right. So we're going to have 6x plus 32 should equal -4 again, but this time we're plugging in an x value of -6. So I'm going to replace my x value here with a -6 this time, and remember they're multiplying because they were a coefficient and variable sitting next to each other. I'm going to add 32 to that and see if it equals -4. 6 times -6 is -36 because a positive times a negative is a negative. I have 36 negatives adding with 32 positives, so I do have more negatives than positives, and 32 of them will cancel out, so our answer should be -4. And I can see that that is equal to what I expected it to equal. So that means that this is true, and so the solution to the equation should be x equals -6. Now to just double check this last one, I have 6x plus 32 should equal -4, and this time it's asking to see whether our x value could be 4. If I go ahead and plug this in, it would be 6 times 4 plus 32 should equal -4. When I add those together at the end here, I'm left with 56 equals -4. So that is an incorrect statement. 56 is not equal to -4. Just like earlier, we got 26 was not equal to -4. So both of those were not solutions to our equation, but x equals -6 is a solution to our equation. In our next section, it says check the answers given by the students below, and we're going to figure out which students did their work correctly and which ones did not. Now, we have not learned how to solve equations yet, but I do have 3 different examples here of student work and what we commonly see as mistakes and correct work, and then we're going to check this to see if we get it right. So the first student is Taylor. Her equation was h plus 7 is supposed to equal 10. She added 7 to both sides of the equation here and said that that would mean that h should equal 17. So if she is checking her work, she's going to rewrite her equation that she started with, and she's going to replace the h value in her problem with the h value that she got in her answer. So we'll replace it with 17. We're going to add 7 to it, and it should equal 10 if this is the true solution. Well, 17 plus 7 is 24, and that does not equal 10. So unfortunately, Taylor is incorrect. So this would tell Taylor, okay, I did not solve this correctly because that value for h did not make my equation true. So she's going to need to go back and make some corrections on her work before she moves on to the next problem. If I take a look over here at Caden's work, Caden had h plus 7 equals 10 again. Instead of adding 7, she subtracted 7, and then on the right side, she added 7. So she's doing two different things on either side, whereas Taylor did two of the same thing on either side. So let's see if that works. Well, Caden got the same answer that Taylor did and said that, well, h should be 17. So if we plug that into the original problem that Caden had, h plus 7 should equal 10. If I replace my h with 17, add 7, does it equal 10? No, 24 is not equivalent to 10. So unfortunately, Caden did not get the right answer either. So hopefully Carter did the work right. Over here, we have the equation h plus 7 equals 10 again. Carter this time subtracted 7 from the left side and subtracted 7 from the right side. So he did the same thing on both sides of the equal sign to keep things equal or balanced. And what he really did here is he took 7 away from either side. What that does is that positive 7 and negative 7 turn into 0. And that leaves us with h equals 10 minus 7, which is 3. So he got a slightly different answer. We're going to test it out and see if he did it right. So we have h plus 7 should equal 10. This time we're plugging in an h value of 3. And 3 plus 7 does equal 10. So 10 equals 10 gets us that true solution right there, meaning that Carter did his work correctly and got the right answer. So the reason that we're learning how to do this is because as you're starting to solve equations, it's very common that we see students use a plus on either side where they should be doing the opposite of subtraction, or they do one operation to one side and one to the other where it is not equal. And we want to make sure that we are keeping things equal on either sides of the equation. So those are just some common mistakes that we see, and I wanted to use them as an example of why we want to check our work because it is easy to make those mistakes and we can go back and fix our work if we check it and know that, hey, that didn't work. I need to go back and solve this again. So the students that solved their equation correctly were Carter, and the students that made a mistake, were Caden and Taylor. And I'm going to highlight those mistakes for you. You can add this on your paper if you want. So Taylor did not add, or she added 7 on both sides, but because there was already a plus 7, we should have subtracted. And Caden did 2 of the wrong operation. So she did minus 7 on one side, which is a good start, but then she did not make it equal on the other side and added 7 instead. So both of those were the mistakes that they had there. And Carter did the work correctly by subtracting 7 from each side. So again, we haven't learned how to actually solve this yet, so I'm more worried about do you know how to check this work right now? But just as a little preview of where we're going, this is kind of what we're going to be looking at. In the last part here, if you think you're getting the point of how we're trying to solve this, you can go ahead and pause and see if any of these are correct. I will say there's a little typo right here. This should say 2x because we're plugging in an x value here. So if you're ready, go ahead and pause and try them out. Otherwise, follow along with me and keep listening on how to do this. So we're going to check the following answers to determine if they are true or false. So this equation says 22 should equal 3x plus 18 when x is 1. So we're going to test it out. We'll replace our x value with a 1 here. Remember, when we have a variable and a coefficient next to each other, we're going to multiply. So this becomes 3 times 1 plus 18 should equal 22. 3 times 1 is 3. We add 18 to that, and that becomes 21, which is not 22. They're close, but it's not equal, and therefore x equals 1 is not the solution to this equation, so that would not be true. In the second one, we have 25 minus 2x equals 17, and we are replacing our x value this time with 4. Again, we have 2 sitting next to x, so a coefficient with a variable, so right there that is hiding multiplication. So we're going to put 2 times 4 there. And that's supposed to equal 17. So 25 minus 2 times 4 is 8. And then we can subtract now that we finished our multiplication. 25 minus 8 is 17. And 17 is equal to what we expected. So therefore that should be correct. And this would be a true solution to this equation. In the last example, we have negative 2x minus 7 should equal 13 if x is equal to 10. So we'll check that out and test to see if it works. So negative 2 is going to be multiplied by 10. We're going to subtract 7 and see if we get 13. Negative 2 times positive 10 makes negative 20. And if I'm subtracting 7 from that, remember we can rewrite this as plus negative 7. So I've got 20 negatives and 7 negatives, and when I combine them, that would make 27 negatives, which is definitely not equivalent to positive 13. So this is not a true solution for that equation. So the only equation here that was true was this middle one. The other two, if that was the solution that you got while you were working through, you would know, okay, I need to go back and resolve my work here.